All right there. Hello, my name is Finn Yingek, and this is my first lab for Physics 2212. So I'll just be going over that. So first off, the experiment itself was just to put a charged piece of that piece of tape, suspend it over another one, and record the suspension of the tape in order to calculate a few things, calculate the total number of atoms in the sticky layer of the tape, the net force that is suspending the tape, that'd be the electric force of that charged tape that you charge, and from all of this, the number of electrons that were displaced from the tape. So we've got some fundamental forces and functions of physics at work here. The first being Coulomb's law, which is F equals K, Q1, Q2 over the magnitude of R squared times R. The unit vector R, that would be the direction. Then we've got Newton's second law being force equals mass times acceleration. That's going to be important for calculating gravity and finding out how those forces interact. Then so a couple assumptions for this is that first off, the tapes are going to be treated as point charges to simplify the calculations. And there's no air resistance or friction or any kind of forces like that that are going to impact the calculations. Here's some experiment results, just some measurements that I needed for the calculations from the experiment, which was the length of the tape being 0.1 meters, that's 10 centimeters. Mass of the tape being 1 gram or 0.0001 kilograms. The distance between those two tapes would be 0.025 meters. That's after it's been charged and it's sort of hovering there. So that's 0.025 meters. All right, some calculations. So as I was looking at this first thing, the most obvious thing to do would be to calculate the force of gravity on the upper piece of tape, which is very simple. It's just force equals mass times the gravitational constant, acceleration, which is our 0.0001 kilograms times 9.8 meters per second squared, which comes out to 9.8 times 10 to the negative fourth newtons in the minus y direction. So it's pulling it down. Then we've got the magnitude of the electric force on the top piece of tape, which is actually going to be just the opposite of that gravitational force because it's not moving. We know acceleration is 0, so force is equivalent. Net force in the y direction is going to be 0, so that'll be exactly the same. 9.8 times 10 to the negative fourth newtons, except it'll be in the positive y direction because it's pushing it up. Then the charge of each piece of tape. If you do some algebra on the Coulomb's law, then you can take, Q. Another assumption is that both the charges on each piece of tape is the same. So Q equals square root R squared times 1 over K times the electric force, which we've got up here. And that's equal to 7.425 times 10 to the negative 8 coulombs. Now we can find out how many electrons are missing by simply dividing that charge by the charge for a single electron, which gives us 4.64 times 10 to the 11th electrons. And then we have to do something with the atoms on the sticky, to find the atoms on the sticky surface of the tape, which the numbers we needed for that were given in the experiment. Because that area of the atom was approximated to be 1 times 10 to the negative 10th meters. So square all of that to get the area. And then the surface of my tape, which was 2 centimeters by 10 centimeters, was easy to calculate to be 4 times 10 to the negative 3rd meters squared. Then divide that by the area of the atom to get that there are 4 times 10 to the 17th atoms. And then we can get the ratio of electrons to atoms and find that 1.16 times 10 to the negative 6 electrons were taken from each atom. In other words, there are many more atoms than electrons on this, than electrons were taken on this piece of tape. So most atoms did not lose any electrons in this transfer, but those that did, was enough to cause this force. Then I made a glow script model that is pretty simple. It just shows 2-point charges being the same charge that simulate the two pieces of tape. That green arrow is going to be gravity pulling the top piece of tape down, while the yellow one is the electric force. You can see they're equal, so it's not moving, it's suspended in the air. That's a simple model. And then just a couple of questions. So what if the electrons had a positive charge and the protons had a negative charge? What would change about the observations you made with your tapes and other charged objects? So that would change some things, but the observations would still be the same because in that case, the tape would have a negative charge, but both pieces of tape would have a negative charge. So then they would be repelling each other. And the top tape would still be suspended the exact same amount, assuming the same number of electrons were taken off of it. And then why is it important to handle the charged tapes as little as possible? What happens when you touch them or do whatever? So that's also pretty clear. If the tape has a charge and you touch it or touch it to its surface or anything, then there can be a transfer of electrons between the tape and that surface, just the same as when you charge the tape in the first place, which changes the charge of it. So if you touch it to your hand or whatever, then electrons may jump between them and it can be neutralized, and then it won't have the properties of that charged piece of tape. All right, that's all for this lab. Thank you very much.